Hello everyone, today I am going to deliver a lecture on wind load calculation as per high-rise building as per ASCE-7-05 and BNBC-2020. So let's start how to calculate here. So I'll just calculating as per ASCE-7. This is the ASCE-7-05 minimum design load calculation, and BNBC, which is Bangladesh National Building Code 2020. Okay, let's start. Here is the calculation. I will try to discuss with you. We calculate the design of wind load. The following building, the building is given instruction. The following building for the whole building. Okay, the rectangular 72.5 72 meter into 48 meter, which is length is 72 and width is 48 meter, and 6 stories. So number of stories will be 6. Hospital building. Okay, story height in 3 meters. So each story is contained in 3 meter. The building is located in Dhaka city. It is situated in Bangladesh, and the exposure category is given A. So we have to calculate the this wind load as per BNBC and or ASCE-7-05. Okay, so let's start. So we know the required formula according to BNBC. So we can see here we have used method 2, which is analytical procedure. So that's why we will be using this formula. So before going to here, I'm just closing this and closing this. Okay, I'm just going to ASCE-7-05. So ASCE-7-05, the velocity pressure is given this formula. If we use this formula, then the value will be pound per feet square. And if we use the SI metric unit, then the formula will be used, and the pressure will be kilonewton per meter square. And keep in mind, then the velocity will be meter per second. So let's see what will be we needed. Okay, so we can use as per we have been seen. We have been using main wind resisting forcing system, which is MWFRS system, and we have used analytical method 2, or method 2, which is analytical procedure. There is another method we have been seen here, the process 1, simplified procedure, but we will not use the simplified procedure. Rather than we will use the analytical procedure. Okay. So let's see here, the basic wind speed is given is B, and the special wind region is given here, and we have to give the wind directionality factor, which is KD, and importance factor, which is I, and exposure, which is will be given exposure category 1 to C. It will be depends on surface roughness or something. The wind direction and stories. So surface roughness, we have been see categories, different categories. Surface roughness B, surface roughness C, and surface roughness D. So exposure category, there are different exposure category. Exposure B. So if we see the surface roughness B, it is for urban and suburban, and surface roughness C, it is for open terrain, and surface roughness D and flood and underwater. Okay. So let's see another, which is the topography factor, which is KZ, and the formula is given there, but we will find out here. And the Gust effect factor, we have been seen G, but it will be mostly we have been used 0.85. And the velocity, finally we have to calculate we have to use this formula for pressure velocity. Okay. And then we have to go the final destination, with the main we will use main wind force resisting system for building a rigid building all height. That means we have been used the high-rise building also. That's why we have been used this formula. So this is our final equation. we are getting the Q from here. This is the velocity pressure. After finding the Q velocity pressure, we will using this formula for getting all the pressure or all the forces. So we can see Q which is given as a windward and another Q is a leeward, and the problem is the value of GCpi. So we have been seeing the GCpi internal coefficient, and all the parameters given. G is Gust effect factor, it is mostly 0.85, and Cp which is external pressure. Okay, and this is the low rise, and another formula we have been seeing here. This formula is using only low rise or steel shed building, and GCpi we have been used the internal pressure, and GCpi F is external pressure. Okay, so mainly we have been using today is this formula, not this, as we have been calculating wall height. Okay, let's see. We've been seeing here the wall height. We've been use this formula. Okay, let's start. So as we know, we have to find out QZ as per from our this formula, or getting from formula, and then we have to calculate P, and how we'll get the QZ. It is given in BNBC section 6.2.7 and page number 3137, and B will be meter per second. And we have to calculate the P. This is the very important formula, and unit will be kilometer per meter square, and it is also given section 6.2.19 and page number 3138. Okay, so we've been seeing QZ, where is the velocity pressure exposure, which is given BNBC 6.2.11, which is page number 3184. So let's go 3184. Okay, we have to go 3184. So give me some minutes. Okay, this is the 3184. So we have been seeing here the velocity pressure of KZ may be determined of the formula, which is given the Z, when the Z value is greater than 4.75 but less than Z, then we have been use this formula. Otherwise, when the Z value is less than 4.57, then we will use this formula. Okay, there is another parameter which we can use, the pressure coefficient KZ and KS and KZ. We can use above the height, ground level. We can use also this chart, but we will not using this chart today. Rather than we will use it is depend of exposure category 1 to 3 and case 1 2 and 1 2 and C. But we will using this formula today, as we have been calculating the high rise building. Okay, so we have been founding here. So KZ, we have been found the topography factor. We have been seen here the 1, and KD, which is wind directionality factor 0.85, is given 3184. KD we have been so let's see where is the KD. This is the KD, wind directionality factor. As we have, most of the cases we have been using building, which is the main wind force. That's why we have been using 0.85. It is a maximum time wind directionality factor KD is 0.85. Okay. So basic wind speed is meter per second. It is depend on a region by region. So if you go to the table 6.2.4 or 3181. Okay, so sorry. This is the basic wind speed, which is given in table, as we have been calculating Dhaka. Then our value wind velocity speed will be meter per second, which is 65.7 meter per second. If we convert mile per hour, then we have to go multiply with 2.265. Okay, and the importance factor we have been found here, which is 3182 page importance factor. So let's go to importance factor. This is the importance factor for wind. This is for in north earthquake. If we go to the earthquake, then we have to go to 3191 page or table 6.2.7. So it will be depends on our occupancy category. So if we select occupancy category 2, then our cyclone prone or regional cyclone prone region with velocity 38 to 44 meter per second, then we have been used this equation, this value, as we have been found 1. So I will select this one 1 to 3, then we have to go to 3161 page. If we go to 3161 page, I am just taking here 3161 page. This is the 3161 page. This is the 3161 page. So after going there, we have been select our this is the occupation category of building of structure for flood, surge and wind and earthquake. So we've been seeing lots of here the occupancy category 1 of it is for agriculture building and certain temporary, and 2 for all other building. We will using 2. Why 2? Because we have been seeing here number 1 is we have been using agriculture, number 2 we will using the building and other mixture with daycare facilities with capacity is greater than 115, and we have been use the e-school, then we will use category 3, and the heavy loaded structure we can use the power generation and water treatment plant also. So we can see another one 4. What is the 4? This is the 4. It is for hospital, fire rescue and ambulance. If we use this type of building design, then we can select the occupation category 4. But as we have been seen, our building is normal building, residential. So that's why we've been using from this type of. Okay, so let's see. Okay, so we will be taking from here. So Gust effect factor 0.85 31. If we go to the section 2.478 or 3134, then we have been calculating the Gust effect factor. It was the maximum we've been seeing 0.85. So if we go to the here the 3134, okay, 31. I'm just going back. Sorry for that interrupt. 3134. Okay, this is I have already discussed the importance factor I, and exposure category I will go to the next, and now this is the Gust effect factor. So we've been seeing the Gust effect factor for rigid structure and classify, and the effect shall be taken 0.85. So this is the Gust effect factor 0.85. And rigid, how will calculate the rigid structure? If the time period is less than 1, then rigid structure. If you calculate the flexible structure when the time period is greater than 1, then it will be flexible structure. And QZ velocity pressure, as we have been here, QZ we have been found, and design to wind pressure. This is our last formula. We have to apply this formula. Okay, let's see. Let's calculate the bending period, which is T, which is CT into HM divided by HM divided by N. So our building is, we have know the 6 is 6. We know the height of the building is 3, and in number of stories 6. So our total height of the building is 18, which is 3 into 6. So it will be 18, and to the power m, which is 0.90. So you can see the time period is less than 1, so it is the rigid structure. Therefore Gust effect factor will be 0.85, as we have been seen here earlier discussed here. Okay, so now calculate the extension pressure coefficient Cp. This is the important. This is the most important external pressure. For x direction, we have been seeing the our dimension is given 72 is length, and breadth is given 46. So as for x direction, this is the wind case. We've been seeing wind case here. If we given the ratio L by D, which is 6.666, now we have to calculate the Cp. How we calculate? So if we go to the sorry for that. Okay, here here is the pressure coefficient Cp. If we go to there, then we have to see here the surface, which is L by B ratio is given for calculating the pressure coefficient Cp. For windward, the Cp is L by what is the ratio between L by D does not matter, but the Cp value is 0.8. So windward, what is the windward? So if you want to know then windward, then we have to go there. This is the airflow. The air is flowing here. When the airflow is here, then this will be windward, and another, the opposite word will be leeward. Okay, but it will be leeward, but or we can do suction. So we have been seeing wind is going here. Just this is the windward, this is the leeward. If the wind is coming here, this will be windward and it will be leeward. It is taken from decode BD. If the wind is coming from here, this will be windward and that will be leeward. If the wind is coming from here, this will be windward, that will be leeward, and other two side will be sidewall. This will be sidewall, and this will be sidewall. This will be sidewall. Okay, so we've been seen here. I'm just giving here. Okay, so I hope that you can understand, but I'll showing again and again windward and leeward. So if you go to the in our model, we can see if we consider wind is going here, then it will be windward, and if we then it will be leeward, or we can see suction, and others two side, this side and this side will be sidewall. Okay, so these are the windward. Is all for Cp is 0.8. We've been here the windward Cp is 0.8. So sidewall, we've been seeing the sidewall. Sidewall is Cp value is 0.70. These are the constant true value. The problem will be leeward. What will be value will be leeward. So it will be depend on the ratio of L divided by B. So if our L divided by B is ratio 0.006, so the 0.006 is between 0 to 0 to 1. So that's why our Cp value is 0.50. If our L by B ratio is 2, then we have to take in the Cp value is 0.3. Or if we take the Cp value, L by B value is 1.5, then we have to interpolate between 1 and 2, which is given here. Okay, so we have been taken 0.50 as we have been seeing. Our value is 0.006, which is between 1 and 0 and 1. Okay, for y direction, this is the wind direction is y along the 72.5 meter. So the ratio is found 1.5. Okay, the windward load is 0.80. We have been known this value will not change. Will never be changed. This value, sorry, I'm just changing the color. This value and this value will never be changed. It will be same. Sorry here. Oh my God, sorry. Okay, this two value will be not changed, as it will be same. The value will be changed only leeward. Okay, so let's see. This is the sidewall 0.70 and windward 1.80. The leeward will be depend on ratio between L by D. So L by D is given 1.5. and we have been seeing the value 1 and 2 is given here. So we have to interpolate this value between zero point 0.5 to 0.30. So 0.5 to 0.30 we have been seen here. We are taking just assumably if we uh, get the punctual value, then we have to interpolate this. Okay, so we are just taking the sum. That's why we have been taking 0.50 and 0.30 and divided by 2 and found 0.40. Okay, another graph we have been seeing the internal pressure. This will be very important, GCpi. You have to keep in mind again and again and again. Otherwise you will be face a trouble. GCpi. So GCpi is we have been seeing the internal pressure, but it is the plus minus. So what does mean is plus minus? Plus mean when the pressure is going to inward to down, inward to outer, and minus mean when the pressure is going to outward to inward. This is the internal pressure. So we will calculate, and first of we will calculate plus, which is called inward to downward, which is gone to inward to outward, and another we will calculate the outerward to inward, which is minus. Okay, as another note, we did not consider the CP for roof because the roof is flat. We are calculating the flat roof, that's why theta is 0. Therefore force acting vertically in upward direction, such as no lateral component will be exist. For multi-stories RC structure, the vertical force has no physical significance and self-weight of structure is such greater than this force. Okay, so this force and the distribution over span length is very crucial for length weight structure like steel gable, bent or portal frame. So we have been seeing here the GCpi, internal pressure coefficient on building exposure classify. We have been seen here. This is the internal pressure. So internal pressure coefficient is given here. Positive means inward to outer, and negative means outward to inward. And CP is external pressure coefficient. We have already shown here how we will calculate the CP. Okay, so let's see. Given data is 6 stories and floor height given 3, and building size is given here, and hospital type is building type is hospital. So location is Dhaka and exposure category is A. I will get the A. So if we go to the exposure category in a previous slide, sorry for interrupting. Okay. Okay, yeah, I'm going here. The it will be depends on surface roughness category. When surface roughness category, when it is urban and suburban area. When the surface category B, when the building is open terrain. We'll consider the surface category C when the surface is flat and obstacle. Okay. We're considering the location is Dhaka. Okay, so we're equating we're putting all these value for Q, calculating Q. We've been getting KZ, KZ, KZT, KD and B square and I. We have taken all the value here. I have been already shown how we'll taking this value. After taking all these value, we are getting this value 2.5 in KZT. KZ is a height. It will be it will be varying, and KZ will calculate for two type of height. As we have been seen, when Z is less than 4.5, then we will use this formula. And Z is between 4.75 to ZG, then we will using this formula. Okay, so we've been seeing here the 6 stories, and the height is given above all is 6 3 plus 3 6, and 3 plus 3 3 which is 9, and it will be going 18. and alpha is given 7 as we have been taken uh, from the slide. I'm just showing how we'll taking the alpha value of alpha, where okay, just give me some minutes. Basic point speed. Okay, where is the table? Yeah, this is the table. So we are using this table. This is the value of alpha. The table is given here. This is the alpha, the exposure category A. Then alpha will be 1. Oh, sorry, alpha will be 7. I'm just so our exposure category we have been selected A. That's why the alpha will be 7. So we are taking the alpha value is 7. And ZG, how we'll calculate the ZG, as we have been seen 365.76, which is given here, where is ZG 365.76 meter. As our exporter category we have selected is 1, as we are taking here the exposure. It will be in the urban and suburban area, as we have been seen here. Exposure category, yeah, we've been seen here urban and suburban area. That's why the exposure category 1. After calculation, after selecting exposure category 1, then we'll taking the alpha, which is 7, and ZG will be 365.70. It will be depends on the exposure category. Okay, let's start. And the KZ, how we'll calculate the KZ? We just putting all this value in here. From formula, with just equation, we using equation and found the gadget below after all the height of the buildings. And in this way we will calculate gadget, which will be kilonewton per meter square. We have been found his all the value is here, and we have been seeing the QZ is increasing with respect to the height. With height is increased, then KZ is all going to increase. So design wind pressure along x direction, which is B, 72.5 meter, is given in the here. So wind is here, along is here, so wind is here. This case 72.5, 72 along x direction. Along x direction, then that means B will be 72.5. Okay. So this is our formula, final formula. We have been seen again and again, where this is our formula. We have been seen again and again. The problem is finding the GCpi. How will find the GCpi? If we calculate the GCpi, then the calculation will be easy. Okay, let's see how we calculate. We have been seeing the location, the windward, leeward, and side wall, and floor 1 to 3 6, and this is the leeward this wall. We have been seeing how we will calculate windward. This is the windward, this is the leeward or section, and this is the side. Okay, so all parameters given there, and height above 3 meter, 6 meter in the here, and external pressure we have been seeing this Q. I will calculate the Q. Q is given 1.47. We have already found here. This is the Q, 1.47, and consequently 2.19, and last one is 2.91. Okay, so Gust effect factor G we have been taken 0.80, and Cp is we are known the 0.80, as we have been seen all the Cp value for. Okay, we have been taken all the value, this is the Cp value for calculating what external pressure. This is the windward, so windward the Cp value will be 0.80 is always. So internal pressure, what is the internal pressure? Why I'll divide the internal pressure and external pressure. So if we go to the this slide, we've been seeing here is flow here. So this is the figure we've been seeing here. The red figure, I will not consider this because the void is here. Our building is there is no void. That's why we will consider this figure. So let's see the wind pressure is positive or external. This is the red figure. When the wind is going here, it will be external. And what will be the internal or suction? This will be all the load will be internal or suction. Okay, so that's why you've been seeing here the external pressure. And if we go to here, this is the internal pressure and this will be external pressure. This will be external. For positive internal, we have been seeing here. We'll see all the calculation here. Okay, GCpi for we are calculating GCpi. We are multiplying all things, all three together and found 1. If we calculate 1.47 into 1.8 in 180, then we will found the 1. For external wind pressure, so we are just calculating this value. Now we will calculate the external pressure, which is here. Okay, so external pressure we will calculating Qi. We have been found the maximum Qi. It will be gone the Qi. This is the thumb rule. Sorry, you have to take in this. The maximum value of Q will be Qi. You must be memorized that. And maximum external Qi will be also leeward and side wall also. And GCpi we know the plus minus 0.14. How will calculate? How will get this plus minus 80? So if we go to the previous slide, so sorry for interrupting. Okay, GCpi. This is the value of Cp. Okay, this is the GCpi. We have been seeing the enclosed, partially enclosed and open terrain also. We have been seeing here the enclosed classification GCpi. The open building is 0. The partially enclosed we are seeing here 0.55. The enclosed building, as we have been seeing the RC building, enclosed RC building, then it will be plus minus 0.80, 0.18. So that's why we are taking the plus minus 0.80. So if we multiply this, then it will be plus minus 0.20, 2.19 and 0.10. It will be plus minus 40. So we are just taken first time we have been taking plus 40 and another time is taken the minus 40. Okay, so let's see. In the same as we've been taking the location is we know leeward and side wall and taken all the parameter, and exposure G is given as per our previous calculation. We have been just taken all the values here. We just taken 0.814 is last value, 0.14 is was last value, and 0.0 here. That was the external pressure we've been seeing here, and internal we've been found 110 plus 0.40, another is plus minus 0.40. So at first I am taking this value 1 into 1 plane first. I will multiply this, then we will getting this 0.60, and the second time I will taking this value and this value. I will just multiply this value and found 1.40. It will be minus. Okay, so how will calculate here? We've been just taken sorry, I'm just lying. We just know that this value is 0.1, and we know the GCpi for positive we have been taken 0.60. Sorry, it will be not that. I'm just changing color again. I'm just taking the red color, and if I follow this formula, GCpi, which is we've been found 1, and minus for QCpi, this value, as we are considering positive, which is 0.40, we are taking 0.40. 1 minus 0.40, it will be 60. And second one, we know the one value of this value 1, we are just taking here the 1, and another one minus GCpi, we are taking the minus GCpi value, this one, taking 1. So 1 minus 0.401, and it will be given ultimately 1, ultimately negative 1. That's why it will be taken 1.4. So 1 minus and minus 4, it will be 1.4. On the other hand, we have been seen 1 minus and 1 minus 0.4, it will be 6. And in this way we will calculating here. How will calculate? We can see the figure 2 and 3 for positive and negative. So this is the figure 2. We've been seeing 1.8 and last is 0.60. So this is the 60 and 1.8 we've been taking here. The for positive, when the positive pressure is applied, then we will found this value, and the leeward value is 0.93. How will get? This is the leeward value, 1.33. Sorry, 1.33. I'm just changing the color, as I have already mentioned this red color. So this portion I am just taking it is taken from 0.60 to 1.8. So it will be 0.60 to 1.8, and the leeward is consequently it will be 1.33, and the side wall it will be 1.70. Where is side wall? This will be side wall, and that will be side wall for 1.70. If we want to understand here, this will be leeward. So the value will be leeward. Windward. This will be windward. The value will be windward for different floor. It will be 0.60 to 1.30 for if we increase this value, and the leeward value will be minus 1.33. It will be this type, and the side wall we've been seen here. The two type of side wall we've been seen, this side wall and this side wall, and the value will be minus. That means what is the minus and what is the plus? Is we've been seeing the windward is all the value is positive, so that's why it will be going thisward, upward. On the other hand, I'm just showing here the value is not accurate. I'm just using this figure. So we are just using this windward, and leeward how will calculate? This is the minus. That's why it will be acting is like that's why. How will calculate this? Sorry. Okay. This will be using dash value, as we have been using minus value, as we have been seeing here. Sorry, it will be, I'm just interrupting you. This minus, what is mean is plus minus. Plus minus does not matter. Plus minus, if we want to see the plus minus here, when I'm just seeing when we will go to the plus minus, this is the positive value. Positive value, that means it will be go outside to inside house. This will be positive. The all the value is positive. This all the value is positive because we have been using windward. When we considering the leeward, then it will be showing the minus value, because it will be gone inside to outside. So if we go to the here, this is the value inside of the outside, that's why it will be negative value. So we have to keep in mind that we are taking the positive value is here. This is the positive value, it is going outside to inside. When calculating, we've been found the leeward and sidewall. So leeward we've been found minus 1.31. So is not mean it will be this. Never is happen, because it will be happen this way. It will going inward of building to the outside of the building. That's why it will be minus. And we will calculating the plus. That means it will be going on outside to the inside of the building. That's why it will be plus. Okay, I hope that you can understand. And in this way here. So now we'll considering another which is minus GCpi, which is if we calculating we're calculating all this here and found the force is GCpi for negative. So this is the another case is figure, and we're considering the minus GCpi and found this value. So we can give the case 1 is here and case 2 is here for x direction case 1, and this will be x direction case 2. Okay, we've been seen here the minimum is 0.10 and maximum is 1.88. So 1.40 to 1.88 as a windward wall. So windward is applied here for outward to inward pressure. So you can see leeward which is 0.563, which is going minus. That means it will be going inside building to the outside building. So these are the inside building to the outside building. You can see 0.53 is given here. And another one is side wall. It is also negative, so it will be also inside building to the outside of building 0.90. I'm not showing here. It will be act like that. It will be act like that. Point. How much? 0.90. Okay. So if we want to see here the positive negative value here, the way we've been seeing here, all the value is given. If we go to the plan section here, if we go to the I want to understand here the plan section, the minimum value is 0.60 and maximum is 1.0. The average will be taken 80. It will depend on. So it will be windward. So windward we have been I'm just changing color as I am donating this is a red color, the case 1. So we've been taking this will be windward. So windward. So all the value have been found the windward. This is the windward. So we are taking all the value, but we are taking the average value is here. And the leeward we have been found also 1.33. So leeward we have been found 1.33. And the side wall we have been found 1.70. So maybe I have been mistaking here. It will be 1.33, and the side wall will be 1.70. It will be 1.70. Where? Sorry, here and here 1.70 for case 1. And case 2 we are calculating. We have been calculating in similarly. So we are taking the windward. This will be windward, and this will be leeward, and this will be side wall, and this will be also side wall. So windward we have been seen taken 1.0 40 to 1.80, just average 1.65, but we are not taking average. It is taken from 1.40 to 1.683. This is the windward. So windward we have been taking from here, and leeward we have been seeing the leeward is found 0.53. This is the 0.53 or 0.93. Sorry, it will be 0.93. It will be 0.53. Okay. And we've been seeing the sidewall, consequently is given here 1.70. 1.70 will be here, 1.90 will be here. It will be that will be 0.90. It will also be 0.90. For external case we've been use 0.30 and 1.30 is here, 1.30. For external case here we've been use 0.93. This will be 0.93 is here. Okay, so I hope that you can understand. So let's see another, which is for the simplicity, the considering loop diagram to calculate the total load design wind pedal x direction. Just we are taking the bay distance, as we know the height, and the dimension breadth is 72. The tributary height is 3. So tributary area will be 72 into 3. That's why it will be 216. We just multiplying tributary area. The external pressure will be known 1, and external force will be if we calculate multiply with this value, then we will found this value. And leeward, it will be windward. For leeward we have been found 0.93. So if we multiply this value, the tributary area into external GCpi 0.93, then it will be found the force. Okay, if we only calculate in breadth, then it will be for kilonewton per meter, but it will be but we are calculating is here as a load kilonewton. That's why we are using tributary area. If we calculate if we want to induce in stat kilonewton per meter, then we have to just using the bay distance, this distance also, bay distance. So center to center distance is called bay distance. For I will say this portion and this portion will be bay distance. Just we are just using bay distance. Bay distance into this and bay distance into this, then we will found this value and this value. And in this way we will calculating all this value, and total force we have been found in x direction 2565.16. So we've been seeing here the value, all the value is increasing with the height. So it will 216 into 263 and 287 and 302, and last one it is decreases as it is highest value. Okay, so I hope that it will complete it in x direction. If we want to see in considering in this y direction, this is the y direction. If we considering this value where this y direction, this y direction, then wind will be changed. So let's see. I will calculate. Okay, so if we if we calculating in this direction, wind is going this direction, then it will be windward and it will be leeward, and others two side will be sidewall. Okay, so we've been seeing along the x direction, then B will be 48. Okay, so location we've been seeing the windward, leeward and sidewall. So floor is given 1 to 3 to 6, and external pressure we've been known Q is given 1.47, as we have been taken the previously 1.47. We've been taken here Q value of Q we've been taken 1.472, 2.19. All the Q values have been already taken. Okay, so 1.47 to 2.19. So 2.19 will be the internal pressure also. As we know that it will be similar value, and it will be similar. So we know that G is 0.85 is constant and Cp is 0.80 constant. So GCpi will be multiply these three, then we will found this value. If we multiply these three, then we will found this value. Consequently, we will found this value here, and we know that the maximum Q is leeward, and we will considering windward and external Qi, and in this way we will calculate the windward. So now we are getting the external it will taking the internal, now we will taking the external force. So Qi is given, maximum value is taken here. GCpi we know 0.1 plus minus 0.10. So if we calculate in plus, then it will GCP. If we calculate this value 2.19 into plus minus 8, then we will find plus minus 40. So that's why we are taking one time is positive 0.40 and another is negative 0.40. Okay, we're just taking the point here before here. So we're focusing this here. So I'm just changing color here. So as we know the all the height and breadth and tributary height, and that will be tributary area. If we multiply this, then it will be tributary area. And windward, so external pressure we've been taking 0.1 to 1.48, as we have been seen here, 1.1 to 1.48. This value, all this value we are taking here for external pressure. We are just taking GCpi, QGCi, QGCi. We are taking 1, and last one 1.48. And the force will be, if we calculating here tributary area, then it will be a force acting like this. For if we calculate, if we multiply this value and this value, then it will be found there. If we multiply to this value and found this value here. So leeward, now we will calculate the leeward. This is the leeward, just I am changing the color here. The leeward internal pressure, so we're just taking a plus minus one time is plus 40 and another is plus 40. So leeward in just minus 0.70, it will be constant, 0.70 it been found here. So it been here 0.70 it been found leeward. The external pressure we been found in here. So all this here, then external we multiply with the tributary area. So if you see here and this here, and force will be like this, and total load we have been calculating in this way. So you can we have been seeing the all the forces, stress pressure is increasing between 0.1 to 1.4 as external pressure. So we've been taking the external pressure. This is the external coefficient for 1 to 1.48, 1 to 1.48, and internal pressure is 0.70. 0.70 is given here. So in this way we are seeing here the load is going here, so it will be a windward. I am just saying windward. This will be leeward 0.70. Windward is given here, and this is the side wall 0.30 and 0.30. And as a wind is given here, so it will be windward will be positive value, and this will be negative, this will be negative, this will be negative, because positive is acting outside to the inside building, and negative value is acting inside building to the outside, inside building to the outside. We have been seen and previously here. the negative 0.70 and 0.30. So 0.70 and 0.30, all the negative value is given here. So I hope that you can understand. If you don't understand, then let me know. I'm just giving a summary again. We have to calculate the wind load as per our ASCE-7. So method we have been using analytical, and force QZ is where velocity pressure is given this formula, and pressure design wind pressure we will calculating here, and all the parameter we have been found here, and after parameter found, then QZ will be completed. So problem will be GCpi. So let's see, calculating it will be resisting and putting all these below, and after the getting all these below, we are putting Q below. So we are getting Q below in normally, there will be no problem at all. So Z below, and we have been founding to Q value is with respect to QZ. Just problem will be GCP. How we calculate GCpi? GCpi will be two type. Like external, we have been seeing the here the external pressure we have been calculating firstly, and just here the external pressure we have been seeing the first of all. This is the external pressure. We have been calculating all this parameter, and internal pressure is GCpi. We are just taking GCpi. It is complicated as we have been taking GCpi was positive and negative value. We have been seeing here GCpi is given first time is positive 0.10 and another is negative 10. Is positive below GCpi internal pressure surface, and negative value is applied for all internal surface. Okay. So positive value which is given positive, and minus sign is significant. Positive is toward, which is outside building to the inside building, and negative sign is away from the internal surface, which is inside building to the outside building. Okay. So these are the important. So that's why we are taking the two type of GCpi. First time is taking the point plus minus positive. So if we calculate in positive, then we will get founding this. Then if we calculate with negative, then we will found this below. We are taking here the negative below will be here. Okay. So after founding this, then we will calculate the final wind pressure. So external, we are calculating all external value is here. So there is no problem in external. The problem will be internal. So after founding this value, we are just putting GCpi. We are just following this format. There is no problem in internal and external. We are just putting this here Q1 value, and GCpi we are considering positive, then we will found 0.40. If we are considering negative, then we will found this value. After this value, we are finding this value. So this is the case one, as we are considering positive GCpi or for positive internal pressure or positive GCpi, and this is the considering for minus negative GCpi. So there will be two cases in x direction as per my point. So x value we have been found internal pressure. After all, the internal pressure is found here. So this is the internal pressure, and this will be external pressure or this will be external pressure or suction, and we've been seen here internal pressure, which is windward, and this will be leeward, and this will be sidewall, and this will be sidewall. This will be sidewall. Okay. And this way when we calculating the internal, which is negative GCpi, there is no internal external. If you calculate minus GCpi, then it will be another case. So it will be in x direction, which is toward, which is windward. We have been found windward below, and this is the leeward. So this is the leeward, and the sidewall is given found in here. So in this way we can calculating the force. If we want to force total force, we can calculating it, just calculating tributary area, tributary area. If we putting is in stat flow, then it will be only tributary length, not tributary area. Then we will be found this type of forces. So the final forces will be here increasing with the story. All of the height of height increase, then the wind will be increased, and the last one will be decreases. And in the same way, in y direction we will calculating here, all the here we can found here. Okay, thank you everyone. If you have any question, then let me know. I will try to convince you. Thank you everyone. Thanks for your patience.